Welcome to NEXTED, your gateway to mastering embedded systems and IoT with Nexuspace's tech education. In this video, we're diving into one of the most popular microcontroller platforms for beginners and pros alike, Arduino. Whether you're a student, a hobbyist, or an aspiring engineer, this session will get you started with hands-on electronics using Arduino. Let's begin. Arduino is an open-source electronics platform based on easy-to-use hardware and software. It's made for anyone making interactive projects, from blinking LEDs to complex robots. The heart of Arduino is its microcontroller, which we can program using the Arduino IDE. There are several Arduino boards to choose from. The most common is the Arduino Uno, ideal for beginners. Others include the Arduino Nano, Mega, Leonardo, and even IoT-focused boards like the Arduino MKR series. Let's take a closer look at the Arduino Uno. It has 14 digital pins, 6 analog input pins, a USB interface, a power jack, and a reset button. Understanding the pinout is key to interfacing sensors, LEDs, motors, and more. To program your Arduino, you need the Arduino IDE. It's free and available on Windows, Mac, and Linux. Just visit arduino.cc, download, and install the IDE. Let's break down our very first Arduino program, the Blink Sketch. This simple code will make an LED turn on and off every 1 second. We begin with the setup function. In Arduino, setup runs only once when the board is powered on or reset. Inside it, we write pin mode 13 output. This tells the Arduino that pin 13 will be used to send signals out, not receive them. On most Arduino boards, pin 13 is connected to a built-in LED. Next, we have the loop function. This part runs continuously, over and over again. The first command inside the loop is digitalWrite 13 high. This sends a high signal, or 5 volts, to pin 13. In other words, it turns the LED on. Then, we pause the program using delay 1000. This creates a 1-second delay before moving to the next line. Now we write digitalWrite 13 low. This turns the LED off by sending 0 volts to pin 13. Again, we wait 1 second with another delay, 1000. Once the loop is done, it immediately starts again, turning the LED on, waiting, turning it off, and repeating forever. This simple program is a great starting point for learning how microcontrollers work. With just a few lines of code, you're already controlling hardware, and that's the magic of Arduino. Connect your Arduino via USB. In the IDE, select the correct board and port from the Tools menu. Then, hit the Upload button. After compiling, your board should start blinking. Sometimes you'll run into upload issues. Check that the board is connected properly, correct port is selected, and no other application is using the COM port. Restarting the IDE often helps too. Now let's go beyond the built-in LED. Using a breadboard and an external LED with a resistor, we can control more devices. The same code logic applies. Arduino becomes powerful when you read data from the environment using sensors. Let's connect a basic temperature sensor, the LM35, and read analog data using analogRead. Now let's understand how to read analog data using Arduino. In this line, int sensor value equals analogRead, A0, we are reading input from analog pin A0. This could be a signal from a sensor, like a temperature sensor, light sensor, or any device that outputs a varying voltage. AnalogRead, A0, returns a value between 0 and 1023, depending on the voltage level received. 0 represents 0 volts, and 1023 represents 5 volts on most Arduino boards. Next, we want to convert this raw sensor value into actual voltage. We use the formula, float voltage equals sensor value asterisk, 5.0/1023.0. Here, we multiply the sensor reading by 5 volts, then divide by 1023 to scale it down to the correct voltage. The result is stored in a variable named voltage, which now holds the sensor's voltage in volts, as a decimal value. This conversion is useful when you need to interpret real-world values, like temperature or light intensity, from the analog signal. Once you're comfortable with basic projects, explore libraries and modules like LCDs, Bluetooth, Wi-Fi, motors, and even IoT platforms. The Arduino ecosystem is vast and beginner-friendly. That's your first step into the world of embedded systems using Arduino. Stay tuned with NEXTED as we explore real-world applications, sensors, IoT, and beyond. Like, share, and subscribe to Nexuspaces to keep learning.